Welcome to Tech TV.
Good day, everyone. Welcome to Tech TV. Today we'll be discussing on relays and contactors. These two components are very, very important in electrical construction. So, and they work similarly. That is, the mode of operation, they are very similar. So we're going to start with the relays, and then also at the end we're going to compare the two together and see in which application can you use relay, then what also application can you use a contactor. Okay, when we talk about relay, in the relay there is a coil which is common to both sides. Both contactors and relay, they work on the coil also. So let's say here is the energizing, this one you power with, for example, you can power it with a 12 volts. You just see 12 volts battery, 12 volts DC. Then once this relay is powered, when this coil is powered, then here there are contacts, 3 contacts here for the simple relay. It has a magnet that actually is something like this. There is another contact here. There is another contact. Okay. Now remember in our last video we talked about the normally closed and normally open concepts. So in this case, you can see here, this is a normally closed contact here. So this is NC, and this is what? NO. That is normally open. Then in relay, there is another third one which is called the common. So what actually happens is, let's say there is a switch here. Now, once this switch is closed, this common is going to move. This common contact is going to move because of this magnet. This coil will be magnetized. The solenoid will be magnetized and attract this spring, whereby this move from here to the what? To the normally open. So in other words, what we're going to have here now is going to be like this. This is going to move to this point here now. Our common is going to change the position to this point here. So whenever, if this coil is also disabled, if the switch is off again, the switch is open, then it comes back again to its normally closed. So in other words, unlike a switch, push-up button switch whereby you need to press. If you press, the contact can change from normally open to normally closed. Then this one is a kind of a system whereby you use the what? You use the source of electricity to power. So it can work in automatic direction. Like once you power it, then it leaves from normally closed to normally open. But when it's not powered, the common is connected to normally closed. That is just the basic concept of a relay. So from here now you can see that the applications is something like maybe you want to change power from one point to another, then you can use this. So another, for example, you can connect maybe here now the common contact can be connected to maybe let's say electricity or something, like maybe I want to on a bulb now. So let's say I want this contact to help with bulb. So I can just design my bulb here. Let's say this is my bulb, then I can connect this one to the neutral. This one goes to my neutral pole. Then let's say this is my life now. This is my 220 volts AC. So now what I do here now is I just So I can do this. I can connect this one to my common here. So now I can connect this one to my common. So it simply means if I connect this to my common, if I connect this common, I mean the normally close here, it means if whenever this DC is off, there will be power. But immediately there is a power to this, then what happens there is going to cut off this. It's going to cut off the power and take it to this one. Then there will be no flow of electricity. So this bulb is going to be off. So likewise also, I can decide to connect it like this. Connecting this way. So like this. So this simply means when the power is, these are my normally closed and this is my normally open. When this is not energized, then there won't be power here. But immediately it's energized, there will be power. So different things that application that we can use it for. So another thing that we need to look at under the relays, there are different types of relays. For you to choose the relay that you need to use for a particular work, there are a lot of factors that you need to check on. The first one, you need to look at the voltage. What is the voltage of the relay that you want? Because when you look at the relay, especially the relay can be driven from 5 volts, and a relay of 5 volts DC. You can have 12 volts DC. There are 24 volts DC. There are 36 to 48 volts DC. And also you can have relay of a 110 volt AC, 220 volts AC. So you need to check that. Even also you can have a 24 volt AC. You can have a 24 volt AC, 48 volt AC relay. So the first thing that will determine the choice of your relay is you have to look at your design, which of these that you will need. Are you working on the DC for a DC source? Maybe what you want to use is DC, then you need to consider your DC power relay. Then you also need to check what is the maximum voltage you are working on. If, for example, you are working on a project of 12 volts, so it's either you use a 5 volt or you use a 12 volts. So it will be not necessary for you to choose a relay of 24 volts because your power will not be able to work on it. Your supply will not be able to power your relay. So also if you are working on AC project, then it will be advisable to choose your AC 220 to 240 volts. So directly, because like in South Africa we use 220 to 240 volts. So you can depend on if you have to use an AC, then it means here you need a transformer. You need a transformer to step down your 220 to 24 volts. In some of the machineries you can find this there. Especially when you open any control panel of a machine and there is a transformer there. Then the first thing that I need to tell you that the relays or the contactor they use there is what? It's a AC. It's of a lower voltage AC like 24 volt or 48 volts. Then another thing that can determine the choice is then you have to look at the current. The current of, especially the current of your contacts. The contact, your normally closed and the normally open contacts. This contact here, then you need to look at this. What is the contact current? We have the one for 5 amps, 10 amps, 30 amps. The big ones are 100 amps. Then you need to check in your project. What do you want to use your output relay to do? Maybe for example now you just want to use your relay to power a bulb of a lamp of 220 volts, 100 watts. Then in that case you will not need a big current, because if you calculate your current, like power is equal to what? Power is equal to high V, then you can see that your current your current there will be like 100 watt divided by what? 220, which is even less than 0.5, which is about 0, around 0.6 something. So it's less than 1 amps. So in that case now you can choose your 5 amps. But if you are working with maybe your power, you want to power something like your output voltage now, maybe you want to power the machines of 220 volts of about 5 kilowatts. 5 kilowatts. Then if you check here now, that's about 5,000 divided by 220. And in this case, then you can go for 10 amps. So depending on the current, so you need to get your current before choosing the power of your relays. Now, when we compare this relay to contactors, then also before we go to contactors, you must know, we talk about the poles of a relay. Depending on, there are some relays, like example, you can see, these are relays. Like this one is a 10 amps 12 volt relays. Then there's also 10 amps relays. You can see, this is 110. Yeah, this is 110 volts, 10 amps relays. This is 220, also 10 amps relays. So depending on the type of work they are doing. The another thing that we need to look at in relays, there are something that we call the poles. Like when you see some relays, this is a set of a contacts. This is a one-pole relay. That is, a one-pole relay consists of 3 pins. Basically, a simple relay has 5 pins. Contact 1 for your power for the coil, that is your contact 1. Contact 2 for the second part of the coil. Then contact 3, your common. Then contact 4, your normally close. Then contact 5 is your normally open. So this is basically you have 5 pins. But there are some relay also that have 4 pins. Maybe in case they don't need a normally close, they just need the normally open, then the manufacturer will have cut off this. So there you just have only 4. So, oh, thank you, it is wrong. This is normally close, right? It's supposed to be normally close, and these are common here. These are common. Okay? Then, if the contactor, maybe they just want it to work on normally open alone, then they will remove this, then you won't find this in there. But though it's still there inside, but outside there it will not be out. The pin will not be out, then you can have 4. But basically, there are 5. So now we call this is just a single pole. Now there are some relays that have 2 poles. Like they have a set of this like this. So this is a sample of 2 poles relay where you have these contacts in 2 different forms. Then there are 3 poles also. For 2 poles, then it means you're going to have 8 pins. Then for 3 poles, you have 3 like this. It means you're going to have 11 pins. Then for 4 poles, there are 4 poles. That is, you can 1, 2, 3, 4. You can do different ways. Then you can disengage and engage in 4 different pins at the same time. Those one will have 14 pins. So, an example of I can see here is 5 poles. 1, 2, 3, 4, 5. This is a simple relay. You can see this. Now this one is 1, 2, 3, 4, 5, 6, 7, 8. This is a 2-pole relay. Then also this is also 2-pole relays. There are 11 pins and 14 pins also. So that's all about a relay. Then we will talk about contactor. Contactors operation is similar to that of relay, but in contactors here you have still the same normally close and normally open. But in this case there is no common. The contactors, like this is an example of contactors. You can see these are contactors. These are different contactors. Then this is another contactor. So you can see that the contactors are bigger in shape than when you compare to a relay. So it's also working the same way the what we call it, the relay is working, like when the solenoid is energized, then the contact move. But in this case there is no common. So here, if for example, when you look at the contactor, okay, the main part of the contactor is you have these three parts here. Here we have it, they are normally open NO contacts. These are NO contacts, NO contacts, NO contacts. So when this coil is energized, what really happens is this contact here, we call it L1, we call this one L3, we call this one L5. And this one is T2, T4, and T6. So what happens here is once this contact is energized, let's say this, there is power here, then immediately N1 and T2, they are going to be normally closed. So you can see they are normally open now, but once it's energized, N1 and N2 becomes normally closed, becomes a straight line. N3 to F4, straight line. F5 to S6 contacts are connected. So in other words, the contact of N1 is connected to the contact of T2. Then you can see a continuity. N3 to T4 and N5 to what? S6. The importance of this is for 3 phase, so that if you are working on 3 phase, let's say electric motor, then you can connect your red lights, your red line, RL, your blue and your yellow. Then once this is connected, once it is powered, then you can find your R here, you can find this here, and you can find this here. Now, okay? So you can see here now, if you count this now, let's say this is contact 1, this one is called A1, which is your life, and this is A2, which is your neutral. Okay? So if you can count here now, 1, 2, 3, 4, 5, 6, 7, 8. Okay? Apart from that, in every contactor there is always A2s appear 2 times there, in the front and the back. So it is provided there, just it's connected like this, just for easy connection, like depending on how you are installing your contactors. So that if it is in front, then you can find your A2. If it is also at the back, then you can find your A2. Okay. Then, apart from this, every contactor has what we call auxiliary. At least one auxiliary. The simple one has one auxiliary. So that auxiliary is used for control. So depending on the type of control that you are working on, maybe it is that control that will determine for you. Maybe you need a normally open auxiliary or you need a normally closed auxiliary. So this is actually one of the factors that determine the choice of the contactor that you buy in market whenever you want to design something. You need to look at your auxiliary. Actually, this one is common. This one is to be normally open, is for your power. But for control, there is an auxiliary, at least one. In most of the contactors, the simple ones, you have one auxiliary there. So like in this case now, the auxiliary here is normally open. So it is used for your control. So you could have normally open like what we said last week in our last video, if this contact is normally, remember all these ones are normally open, then it means if this one is normally closed, simply means at this stage where this your what do you call it, your contactor is not powered, this is the contacts are connected. Yeah. So the contactors are connected. Then you see normally open, but if it is normally closed, then it means if it is normally open NO. So actually in a simple contactors, you're supposed to have at least, if you check here, that is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Supposed to have 11 pins in a simple contactor. So before we go inside the workshop now to demonstrate how contactor works, the next thing that you need to know about the contactor is also that the choice, also the voltage, the factors, like I've said, I've mentioned one of the factors, like you have to look at it, if do you need a normally closed auxiliary or you need a normally open auxiliary. Then the other factor is about the voltage also of what you are designing. Also, contactor, also we have contactors in DC, also in AC, 12 volts, 24 volts, up to 415 volts. So where you have to use two light, L1 instead of neutral, now there will be what? L2 here. 15 volts on those. Okay. Then also your current also is also power, like we have contactor of 9 amps. That is, the amps in talk is referring to the contact of this 6 contacts here. The 6 contacts here is talking about is what's actually rated your amps, because they are the ones to carry the load. So we have from 4, we have 9 amps, 6 amps, 9 amps, 12 amps, up to 30 amps, like 110 amps, even 900 amps, depending. In a big industry, you have 1,000 amps contactors. So, yeah. Then, before we go to the workshop now, let me quickly speak on these auxiliaries also. There is this attached auxiliaries. In case, if for example, like I said, a normal contactor has only one auxiliaries. Like it could be normally open, like this one is normally open auxiliaries, and here this is a normally closed auxiliaries. So now, let's say in your design, your control, you need more than one auxiliary. Maybe you need 2 or 3 auxiliaries. Then what you need to do is just to buy the attached auxiliaries. Like this one now, this one has 2 auxiliaries, one normally open and normally closed. All you need to do is just to attach it to your contactor. Every contactor, any contactor can attach, so that as the contactor is moving, they can move together with this. It simply means you have 2 auxiliaries here plus 1 here, so you have 3 auxiliaries. If that is not enough, then you can use this one is 4. We have 4 here. So 2 normally closed and 2 normally open. Then you can also attach it. You can also attach it to your contactor, so making 5 auxiliaries now. So I think, so we can go to the workshop now to demonstrate how contactors and relays work. Thank you. Then you can see this is a 220 volt AC contactors, you see, 50 hertz. So here is okay, we can remove the attachment. You can see it here, so you need to check very well before you connect. This is 220 volts, you see. Then if you compare to this one now, you can see here is what, this is 380 volts. So it means this one need 2 live wires, red and blue, but why this one need only one live and 1 neutral. Okay, so now what we want to do now is Mr. Jabulan is going to connect this for us now to A1. Okay, that's okay.
Can put it inside.
Yeah, it's inside. Use it again. Just use it again.
I think it's
okay.
So, yeah.
Okay. Okay, now, okay. Now, okay, bring the meter. So now I want to check the continuity between our L1 and our T2 now, before we plug it.
L1 and T1.
And T2, yeah. Okay, you can see there's no contact there. So, but immediately once I power it, no, put your meter. You can see. You can see there's no contact, but if once I power it, you can see now. If I switch it off now, you see? Okay, let's check the auxiliary. This auxiliary is, auxiliary is normally what? It's normally closed. Can you check? Let's check. It's not powered now. You see, the auxiliary of this one is normally closed. So let's see what is going to happen when you power it now. You see, it becomes open. If I should on it again, you know, it's off now. You see. So that is the. Then if you check also with attached auxiliaries, I'm not sure is this auxiliary working. Okay, let's check. Can you check normally close? Okay, let's check normally open now. You see now, normally open is not, there's no contact, but once I on it, you see it's open. It's now closed now. So now this is how relays operate. Then you can connect whatever you want to connect the other output. So now in this class, we're going to see how you can use the contactors and relays. Thank you.